Hello, geometry students. Today I am recording a video for you for lesson 19. I don't want us to fall further behind in our lessons, especially since I missed the first one back after Christmas. But let me preface this with saying that I am videoing from home, and I do have animals. So if for some reason they become distracting, I will stop the video and restart it. So homework is 19A, B, D, and E all. That has not changed from your syllabus. So I wrote it up here on the board for you. But again, if you have your syllabus, then it is not any different. So today we're going to talk about radicals, okay? The important thing to remember about radicals, we have already been learning about radicals, but the important thing with today's lesson 19 about radicals is that only whole numbers are permitted in the denominator of a fraction. So if you find a radical in the denominator, such like this is not proper. You cannot keep this here. So when we're solving problems dealing with radicals, if this is our answer at the end, we're still not finished, okay? It's still not simplified. And in fact, your homework says simplify the radical expressions. And the first several on your homework are gonna look similar to this, okay? And here's what they want you to do. So we know that the square root undoes the square, right? And that's kind of what we're doing here. But if you find yourself with a problem that ends like this, where the radical is in the denominator, you are going to multiply by the radical. However, if we multiply the denominator by the radical, we also have to multiply the numerator by the radical. So what's going to happen when we do that? Our numerator is going to become 7 radical 2. Radical 2 times radical 2 is radical 4. However, we're not done yet because we still have 7 radical 2, but now this is a square root. So it becomes 2. You can skip this step if that works for you. And I would have known that when I multiply a radical by a radical, it just undoes the radical and becomes the square root. For example, before we move on to our next example in the teacher's manual, if I multiply radical 5 times radical 5, that's going to equal 5. Why? Because radical 5 times radical 5 is 25, which is a perfect square of 5. If I have radical 28 times radical 28, well, guess what? I could go ahead and figure out and multiply on my calculator 28 times 28, but I don't need to do that because the answer is 28, okay? Because it just becomes the perfect square. It like undoes itself. It undoes the radical. Squaring it undoes the radical, okay? We've been saying that for a while now. All right, so let's look at another problem. So the first part of your homework are going to be ones like these. And again, it'll just say simplify, okay? So what we're going to do is we're going to multiply the bottom and the top both by the radical, or what's in the denominator. In this case, it's radical 5. And now when I multiply 3 by radical 5, I get 3 radical 5. And on the bottom, I get 5, right? Now, I could have done square root of 25 here and gone another step and then put 5. But I know that when I multiply two radicals and they're the same, that squaring it just undoes the radical. All right. Let's do this one. What if I have 4 radical 8? Now there are 2 ways that you can do this problem. You can simplify the radical before multiplying by it, or you can just multiply by the radical. And if you look in the book, if that's confusing, I'll explain in a minute. You can look in the book and it'll show you both ways. I am going to encourage you to do it the way that we did this one, okay? Because if I do that, then I multiply both the top and the bottom by radical 8. And I know now that I have 4 radical 8 over 8. And I'm still not done because I have to reduce this fraction, which now I will have 1 radical 8 over 2. I don't think that is correct. Give me just a moment here. Oh, I know why that is not correct. Okay, the reason it is, okay, and we're still not simplified because there's a perfect square in 8. This is where what we were doing when we were working with radicals before comes in, and that's why this one's a little more complicated. So we know that radical 8 can also be 4 times 2, right? Radical 4 times radical 2 will give me radical 8. Why do I do that? Because this is a perfect square. The square root of 4 is 2. So now I have 2 radical 2 over 2, and my 2's can cancel, and I am left with radical 2, okay? All right. So yes, it's a lot of simplifying once we get to this part. I'll show you another way to do this one, and then you can choose to do it the way that works best for you. Okay, again, our problem is 4 radical 8, okay? And I know if I just leave this alone for a minute, I can go ahead and divide this into radical 4 and radical 2, because I know that this is perfect square, right? It's because when I do that, then I have 4 over 2 radical 2, and 4 divided by 2 is 2, right? Radical, give me just a second here. Okay. We can't have a radical. See, why did they do it that way? I'm sorry, they did it. They did it a different way, didn't they? All right. So I can't have a radical in here. So I have to multiply both the bottom and the top by the radical 2. Okay. All right. And now, well, I should have done the 2 first. I'm sorry, guys. Okay. This becomes 2 over radical 2. But I cannot have a radical down here, so I have to multiply the bottom and the top by radical 2. So now I have 2 radical 2 over 2, and the 2's cancel, and I'm left with radical 2. This one's harder for me, and so sorry if I confused you. This one is my preferred method of doing it, but whichever one is easier for you, you can choose to do. Okay, so when I was looking at your homework, like on 19A and 19B, you will have the first, it looks like 6 problems are going to be like this, where you're going to multiply the numerator and the denominator by the radical that's in the denominator and simplify. And then you're going to have problems like this next one that we're going to do. Okay, it does get a little harder, but that's okay. And then I'm going to show you some other things I want you to be aware of before going into this lesson. What if we have 3 radical 2 plus 5 radical 3? Okay. Just like when we add or subtract fractions, I am going to put them up and down instead of across, okay? It's just easier to work with them this way. Before I can combine anything, when I am adding fractions, we have to have a common denominator, right? And I don't have a common denominator. So the first thing that I am going to do is what we did in the first part of this lesson. Here, I'm going to multiply the bottom and the top by radical 2. And I will get 3 radical 2 over 2. I am not going to change this to 1.5 at this point, okay? I'm going to wait till the very end because I know I have an addition problem here, and so that will just make it even more confusing. All right, let's do the same thing here. Multiply the bottom and the top by radical 3, and I will have 5 radical 3 over 3. Okay, everybody with me so far? Now I can find a common denominator because I have the whole number 2 and the whole number 3 in the denominator. I got rid of the radical. My common denominator is going to be 6, okay? 3 times what gives me 6? It's 2, and whatever I do to the bottom, I have to do to the top. So now I have 5 times 2, which is 10 radical 3 over 6. Same thing here. Common denominator is 6. 2 times what number gives me 6? It's 3. Whatever I do to the denominator, I have to do to the numerator. 3 times 3 is 9 square root of 2 over 6. I now have a common denominator, and it is 6. So I simply now put 9 radical 2 plus 10 radical 3 over 6. I can't do anything with these two, okay? Remember when we were adding radicals or subtracting radicals, they had to have the same base or the same radical. And this is radical 2 and this is radical 3. So this is fully simplified. This is our answer. Okay. I know this concept is probably a little more difficult to comprehend, so I'm going to do a few more examples with you. And I want to show you a few things also in case you come across them, even though it's not in the teacher's manual. The teacher's manual this week was very short. I went over everything that was in it. That's why I'm going to add some of my own things to kind of help along. Okay, so a few things before we're going to do another example. Like, let's just go ahead and do that. Let's do another example of what we just did. 2 radical 6 plus 2 radical 5. No, I'm sorry. That is division. Okay. Division. I wanted to do another addition one. Okay, wait. We're going to do another addition one before we get into multiplication and division. All right. Okay. Actually, we'll do a subtraction one. 5 radical 2 over 14 minus 3 radical 2 over, sorry, this is radical 14, over radical 14. Okay, well, we have common radicals here and common radicals here, right? So that's pretty easy because I can do 5 radical 2 minus 3 radical 2. 5 minus 3 is 2 radical 2 and over radical 14, right? Because this is radical 14 and this is radical 14. However, when we get to here, it's kind of like when we get to the end of our fraction and let's say it's 3/6, then it's not fully simplified because then we have to make that into 1/3, right? Same thing here. This is not fully simplified because we cannot have this radical in the denominator. So what I have to do is I have to multiply the bottom and the top by radical 14. And we know when we do that, we're going to have 14 on the bottom because squaring it undoes the radical. And I'm still going to have 2, right? But now I have radical 2 times radical 14, which is radical 28. Because when we multiply radicals, we just multiply what's inside the radicals. But the question I have to ask myself at this point now is it fully reduced? And it is not fully reduced. I don't have a radical in the denominator, which is good. However, 2/14 can be reduced into 1/7, right? Okay, my whole number is now fully reduced. Carry this on down here since I'm out of room. But now I have to ask myself, are there any perfect squares in radical 28? And so I have to start thinking, okay, what are my perfect squares? My perfect squares are 4, what am I doing? Okay, so, yeah, so the square root of 4 is 2. Square root, sorry, I'm like brain dead right now. 25 is 5. 9 is 3, 16 is 4. Okay, so this is where I'm thinking about my perfect squares, right? And I know that 28 can, a factor of 28 would be 2 and 14, okay? And so therefore, I'm gonna now write this, I'm gonna keep my 1/7 the same because that's all already fully reduced. But now I will have radical, I don't want 2 and 14. Sorry. I am 4. 4 times 7 will give me 28. So I'm going to break this into 4 and 7, right? Okay. And now 4 becomes 2. And because this is a perfect square, square root of 4 is 2. I now have 2 radical 7 over 7. And that is finally my final answer. So sometimes these can get really lengthy, okay? So you just have to keep asking yourself, have I fully reduced the whole number part of the fraction, the 2/14? No, I have to do it into 1/7. Now I have to look at that radical. Now that I have reduced the whole part of the fraction, can I reduce the 28? Can it be simplified, the radical 28? And yes, it can. All right. So don't let those scare you. Let's see. What else do I want to show you guys? So I want to show you that we can multiply. Well, let me show you one more addition one. If I have 8 radical 2 plus 2 radical 14, and we're asked to simplify. So we ask ourselves, okay, well, you know what? I don't have a common radical here, so I can't add these. This is fully simplified. So if you come across any of that, any like this in your homework, you can just say fully simplified, all right? Because you're just asking yourself, we can't combine this 8 and this 10 because we don't have a common radical. Okay, I wanted to show you that. What if I have 12 radical 13 divided by 2 radical 13? So 12 divided by 2 is 6, right? Okay, and the radicals cancel each other out. So this is just 6. All right, so I'm showing you some things you might come across because I don't want you to be confused if you do. Okay, that one we just multiply by what's in the radical. Okay, I want to show you, I think we're going to do one more addition problem, and then we're going to do a division problem, and then we'll be done. So 2 more problems. Okay, I just want to make sure you guys are good with this. I have 15 radical 5 plus 20 radical 2. Okay. Well, already I can't even get to a common denominator because I have radicals in my denominator, and I can't have radicals in the denominator. So I am going to set these up and down to make life easier. Okay. I'm going to multiply this by radical 2, and I've got to do that for both the denominator and the numerator. Remember, we always multiply by what is in the denominator, which is radical 2. The square undoes the radical, so now I have 20 radical 2 over 2. Same thing here, I'm going to multiply the bottom and the top by radical 5, because when I do that, squaring it undoes the radical and I'm left with 5, and I have 15 radical 5. Now I have whole numbers in my denominator, 5 and 2. I can find a common denominator. In this case, it's going to be 10. Okay. 2 times what gave me 10, and it's 5. Whatever I do to the bottom, I have to do to the top. 5 times 20 is 100. Yep. Radical 2. 5 times 2 is 10. Whatever I do to the bottom, I have to do to the top. 15 times 2 is 30. Radical 5. I now have a common denominator of 10, right? And so I have 30 radical 5 plus 100 radical 2 over 10. And at this point, I ask myself, am I finished? Am I really completely done? And so some of you would say, yeah, yeah, we're completely done, right? But actually we're not. Because even though these are not the same, the radical 5 and the radical 2, so I can't add them, what I can do is I look at my whole numbers. So when I get to this point, I say, okay, I can't add those, but look at my whole numbers. 30, 110 are all divisible by 10, right? Sorry, I lost my problem that I'm on here. So now that's what I'm going to do. So 30 divided by 10 is 3. 100 divided by 10 is 10. And 10 divided by 10 is 1. I could put this all over 1, but I don't need to. So fully reduced, my answer is 3 radical 5 plus 10 radical 2. Okay, hopefully, I know some of these might be kind of hard, but just keep asking yourself, look at your whole numbers, are they fully reduced? Look at your radicals, are they fully reduced? Okay, the nice thing about this video too is if I'm going too fast for you, you can go back and watch certain sections again. Let's do a division one, sorry. I think we've already done a multiplication one. I'm just trying to come across anything you might have and make sure that I'm covering all my bases. Okay. We have 2 radical 6 divided by 2 radical 5. Okay. And so my 2's cancel, right? So this one is kind of silly. So then I'm left with radical 6 over radical 5. But I know that it's not simplified because I can't have a radical in the denominator. So I have to multiply the bottom and the top by radical 5. When I do that, squaring it undoes the radical and I am left with 5. And radical 6 times radical 5 is radical 30. Okay. So now I just have to ask myself, okay, am I fully reduced? Well, there's this implied 1 here. So when I look at my whole numbers of 1/5, that's fully reduced. I can't reduce 1/5 any further. But what about that 30? Are there any perfect squares in there? You know, can I multiply 4 by something? No, and get 30. Can I multiply 25 by something and get 30? No. What about 9? No. 16? No. So therefore, this is fully reduced and this is the answer. I just wanted to walk you through the process of thinking about that when you're looking at your perfect squares and you're looking at this 30, because you're thinking, well, 30 is a pretty high number, so I might be able to reduce that further. But because 30 is not divisible by 4 or 9 or 16, or even 25 in any of the higher numbers, therefore it is fully reduced. Okay, if you get stuck, reach out, send me an email. I can always find some other YouTube videos, or if there's just like one particular problem you're stuck on, reach out and I can record a video of doing that. All right, have a great day.